This video is for Honors Pre-Calculus. We're continuing with section 7.7. We're talking about determinants. So in this third and final video for the section, we're going to look at how to calculate the determinant of a square matrix. So the determinant of matrix A is going to be equal to the element in the matrix times its corresponding cofactor plus the next element in the row, so first row, second column, so the next element in that row times its cofactor, and so on until you've multiplied each element in the row times its corresponding cofactor, and then you just add it all up. So it sounds a little bit confusing, but we'll go through an example. It won't be too bad. So let's, for example 3, we want to find the determinant of the matrix in example 2. So the matrix in example 2, A, was 3, negative 2, 4, 3, 2, and 1, negative 1, 3, and 6. And then let's also write the cofactors. So the cofactors, cofactor for row 1, column 1 was 9. The cofactor for row 1, column 2 was negative 19. The cofactor for row 1, column 3 was 11. And then moving on to the next row, cofactor 2, 1 was 24. Cofactor for 2, 2, row 2, column 2 was 22. The cofactor for row 2, column 3 was negative 7. And the final row, cofactor for 3, 1, negative 10. Cofactor for 3, 2 was 9. And the cofactor for 3, 3, row 3, column 3 was 12. So we've got our matrix, we've got our cofactors. And according to that formula, the determinant of A, so let's pick this first row here, and its corresponding cofactors are these. So we're going to take the first element, row 1, column 1, and multiply it by the cofactor that corresponds to row 1, column 1. So that's 3 times 9, and then we're going to continue to do that for the whole row, plus negative 2 times negative 19, plus, and then the last one in the row is 4 times 11. And if we calculate all that, we should get 109. So it does take a bit of work to find the determinant of a 3 by 3 matrix. You've got to find some cofactors, and then you'll multiply this out. So we did this with the first row, but this would also work for any other row. So let's take a look at the second row. So let's do the same thing with the second row. So, or the determinant of matrix A. So the second row is 3 times 24 plus 2 times 22 plus 1 times negative 7, and if we calculate that, we will also get 109. And if you haven't guessed already, it's going to work for the third row as well. So let's do that just to double check. And for a little more practice, so the determinant of matrix A, so we have negative 1 times its corresponding cofactor, which is negative 10, plus 3 times 9, plus 6 times 12. And again, if we calculate that, we're going to get 109. So really, to find the determinant, you only need to find the cofactors for one row, which isn't too bad. So you find the cofactors for one row, you'll multiply each element times its corresponding cofactor and find the sum, and you have the determinant. All right, so Next, for a 3 by 3 matrix, we can also use what's called Cramer's rule. So let's rewrite our matrix from example 2. So I've got 3, -2, 4, 3, 2, 1, and -1, 3, 6, and then let's put a little dashed line here. And what I'm going to do is I'm going to repeat these first 2 columns only on the other side of this dashed line. So I'm going to have 3, 3, -1, -2, 2, and 3. And then what we're going to do is I'm going to multiply along these diagonals here. So I'm going to multiply these 3 values. So I have 3 times 2 times 6. And then I'm going to add to that the product of these 3 values. So that's -2 times 1 times -1, and then add to that the product of these 3 values. So plus 4 times 3 times 3. So I'm going to take this sum and subtract from that the product of these 3. So minus 4 times 2 times -1 plus, and then these 3 values, 3 times 1 times 3 plus, and then the product of these 3 values. So that's -2 times 3 times 6. And if we calculate that, we will also get 109. So make sure you know how to find the determinant by hand of a 3 by 3 matrix using the cofactor method, and also by using Cramer's rule. All right, so make sure you practice both of those. All right, now to find the determinant of a 4 by 4 matrix or higher can be very tedious. However, if the matrix is a triangular matrix, which I'll describe in a minute, the process is very simple. So a triangular matrix is a matrix that has zeros above its diagonal, below its diagonal, or both. So let's take a look at a couple of examples. So find the determinant of the following triangular matrix, and you can check using your calculator. There's a determinant feature in your calculator. You won't be able to use it on the non-calculator portion of the assessment, but you can use it for the notes here. So for this triangular matrix, all we need to do to find the determinant is multiply these values along the diagonal. So the determinant of this matrix is going to be 2 times -9 times 3 times 4, which ends up to be -216. So, if I did happen to give you something that was larger than a 3 by 3 and was going to have you calculate it without the use of a calculator, it would be a triangular matrix. And then this last example, you notice it has zeros both above and below the diagonal. So to find the determinant of this matrix, again, all we need to do, since this is a triangular matrix, is multiply the entries along the diagonal. So 4 times 8 times -2 times 1 times -1, which is 64. All right. So we have a couple different ways to calculate the determinant. Again, make sure you know how to do it using Cramer's rule and also using cofactors. If you have any questions, make sure you get those answered, and we'll see you next time.